MSc Reactions in Solution. I'm going to continue with this topic. I have already made a playlist of 6 videos. All include different reactions. I have also made for primary salt effect and secondary salt effect. Before I start with the effect of dielectric constants, I will just brief you about what are the aims of studying this effect. As we know, the kinetics of reaction taking place between ions deviate considerably when compared to the kinetics of reactions taking place among non-electrolytes. These deviations are mainly due to electrostatic force exerted by each ion on the other ion. So, let us consider the effect of the electrolytes on the rates of reactions. We have already in detail studied about primary salt effect, secondary salt effect. The next topic that comes is effect of dielectric constant. Now, according to transition state theory, the expression for the rate constant of general reaction is this. For the reaction of A plus B going to an intermediate AB, which forms products. For that, it is given by Kr is equal to Kt divided by H into K star. Here, K star is the equilibrium constant for this mentioned equilibrium, but it also is related to the free energy of formation. Of the activated complex delta G star by the thermodynamics relationship, that is minus delta G star is equal to RT ln of K star. Therefore, we can say that if we move this here, we can say that ln of K star is equal to minus delta G star divided by RT. In terms of small e, we can write, when we want to change log into ln, we write it as, or you can say ln can also be written as K star is equal to e raised to minus delta G star divided by RT. On substituting this value of K star in this equation, what we get is Kr is equal to Kt by H into e raised to minus delta G star divided by RT. But as you know, in case of ionic reactions, delta G star includes two contributions due to non-electrostatic and electrostatic reactions. So we can say that delta G star is equal to delta G star non-electrostatic plus delta G star electrostatics. If we assume that two ions of charges ZaE and ZA and sorry ZBE, that is if we assume the two ions ZaE having charges ZaE and ZBE are brought together from the distance of infinity to the distance d. From the distance of infinity to distance d to form the activated complex in a medium of dielectric constant d, the amount of work done is given by is equal to integration of from infinity to distance d force into displacement. That will be equal to infinity to distance d force in between these two charges, that will be ZaE ZBE divided by 4 pi epsilon naught d. I assume that you know the 4 pi epsilon naught is a constant value we consider into integration of dx will be 1 by x square dx. If this reaction, as if we assume for 1 mole of gas, each ion, the amount of work done will be given by WE is equal to minus ZAE ZBE divided by 4 pi epsilon naught D into Na divided by D. We are considering for 1 mole of a gas. That is why we are getting this Avogadro number. Since change in free energy delta G is equal to the amount of work done the value of G E star is equal to E star will be equal to WE, work done by electrostatic reaction. So now this equation delta G star will be equal to delta G star non-electrostatic minus, since we are having this negative symbol, we are having E here 2 times, that will be E square minus ZA ZB into E square divided by 4 pi epsilon naught D into Na divided by D. Substituting this value of G star in the expression for Kr, that is here. I'm sorry. In this expression, now what we will get is Kr will be equal to this whole thing as it is. I will write Kt divided by h e raised to minus delta G Ne raised to one divided by RT e raised to ZA ZB E square Na 4 pi epsilon naught d into 1 divided by d into RT. So now Kr will become K naught e raised to, this is minus ZA ZB e square Na divided by 4 pi epsilon naught d into 1 divided by dRT. So what is K naught? K naught is equal to Kt by h e raised to minus delta G star into n e raised to 1 divided by RT. When we take natural logarithms, we can say that ln of Kr is equal to ln of K naught minus, we get rid of this e kind of things when we take natural logarithms, minus ZA ZB e square Na divided by 4 pi epsilon naught d will remain as it is. dRt, we are bringing this here and we are shifting this here. Nothing else we are doing. One divided by 4 pi epsilon naught into d. Now, according to this equation, Kr varies linearly with 1 by d. With a slope of minus ZA, ZB, E square, NA divided by D RT 4 pi epsilon naught. So that was it for effect of concentration. For effect of dielectric constant. You start with the reaction A plus B going into intermediate. A plus B going to the intermediate, which in turn slowly goes to the product side. You come up to finding the Kr, which is linearly proportional to 1 by d. It is having a slope of, you can say ZA, ZB, that is the charges of electrostatic and non-electrostatic ions in the reactions, along with the constants. So that's it for the today's topic. I hope that you have understood. The next topic that I will be taking up is effect of structure of reactivity. So keep watching, keep studying, and do share, like, and subscribe my channel. Have a good night.